अच्छा, हम लोगों ने लास्ट टाइम बात की थी अबाउट द लेटर प्रॉब्लम्स. वी टॉक्ड अबाउट द इक्विलिब्रियम ऑफ फोर्सेस, राइट? एंड वी टॉक्ड अबाउट ये सब चीजें हमने डिस्कस की थी. आज हम बात करेंगे अबाउट द प्रेशर. ठीक है, लेट अस टॉक अबाउट द प्रेशर. ये हमारी लास्ट टास्क थी जिसमें हमने ये चीजें डिस्कस की थी. डेंसिटी, राइट? एंड देन वी मूव ऑन. सो लेट अस बिगिन. You should know that this is very simple, और इसके क्वेश्चंस ही होते हैं जो ज्यादा इंपॉर्टेंट होते हैं डेंसिटी के. You should know that density is, if I talk about density, you should know that the density is defined as mass per unit volume. Right here that density is defined as mass per unit volume, right? And you write the formula of density as mass over volume. ठीक है, हम इसको इस तरह से लिखेंगे, density as mass over volume. Here the density has SI units, which are kilogram per meter cube. Mass is in kilograms, and volume is in meter cube. The density is mass over volume. Here the density has SI units kilogram per meter cube. Mass is in kilograms, volume is in meter cube. And there are other units as well for the density, which are other units are gram per cm cube, right? ये कुछ उसके और units हैं. आप इस density को symbolically लिखते हैं as rho is equal to m over v. ये rho is the symbol for the density, m is the mass, and v is the volume. सबको समझ आ रही है जी everyone? उसके बाद अगर आपको कोई sphere दे दे वो, for example, with a radius r, so you should know that the volume of the sphere is 4/3 pi r cube. The volume of the sphere is 4/3 pi r cube, and the density would be what? You'll write here m over v, where mass is m and volume is this, and you'll be able to calculate the density. 4/3 pi r cube. So this is how you will calculate the density of an object, right? Is that clear? ठीक है, तो ये आप लोगों ने इसका खास ख्याल रखना. We have been given the density of water as 1 gram per cm cube. This is summary 18 paper 1-2. The density of water is 1 gram per cm cube, and the density of glycerine is 1.3. Water is added to a measuring cylinder containing 40 cm cube of glycerine, so that the density of the mixture is 1.1 gram. This is the mixture of the entire mixture, the density of the entire mixture. Assume that the mixing process does not change the total volume of the liquid. What is the volume of water added? So how will you calculate the volume of water added? You have been given the density of water as 1. The density of glycerine is this, right? And what you have to do is, देखिए आपको उन्होंने density दी हुई है water की as 1 gram per cm cube और density दी हुई है glycerine की. We can make a data here. The density of water is 1 gram per cm cube. The density of glycerine is 1.3 gram per cm cube. अच्छा, अब हो क्या रहा है कि जो density of the mixture है, that is 1.1 gram per cm cube. ऐसे ही है. अच्छा, you know that the volume of the water is 40. The volume of glycerine is that we need to. अच्छा, the volume of glycerine is 40. The volume of glycerine is 40. The volume of water is something that we need to find. That is x. अच्छा, अब आपको पता है कि the total density is 1.1. So you should know that 1.1 is the total density. So total density is equal to total mass over total volume. आपके पास जो टोटल मास है यहाँ पे दैट इज डेंसिटी इनटू वॉल्यूम, राइट? इसकी डेंसिटी जो है वाटर की वो है, देखिए ना, टोटल डेंसिटी इज गिवन बाय mass of water plus mass of glycerine over volume of water plus volume of glycerine. Okay, mass of water plus mass of glycerine is equal to volume of water plus volume of glycerine. That will give you the total density, right? Now I can write here the total density as 1.1. The mass of water is density into volume. Density into volume hota hai na? The density of water is 1. Volume of water is x. इसी तरह से density of glycerine is 1.3. The volume of glycerine is 40. अगर आप टोटल वॉल्यूम की बात करें तो टोटल वॉल्यूम है आपके पास 40 plus x. X is the volume of glycerine and x is the volume of water and 40 is the volume of glycerine. अब आप इसको simultaneously solve कर लें. ये हो जाएगा 1.1 is equal to x plus ये आपके पास आ जाएगा यहाँ पे 52 I guess over x plus 40. इसको अब आप solve कर लें इस equation को. तो आप जब इसको solve करेंगे तो आपके पास आंसर 50 आएगा. इस तरह से आप ये इसकी कैलकुलेशन करेंगे. I hope this is clear to all of you. ठीक है जी? I'm going to talk about pressure now. So the pressure is defined as, I'm going to write here that you're very much familiar with this concept, and you should know that the pressure is defined as force per unit area. Remember that. Pressure is defined as force per unit area, where the force F acts perpendicular to the area, right? This is a very important condition here, that the force acts perpendicular to the area. So we have here an object, and this area is A, which is the cross-sectional area here. This is the cross-sectional area that we have. And we have the force which is acting like this. This is the force that we have. Now you should know that by all means that the pressure is force over area. Here force is in newtons and area is in meters square, right? The force is in Newton, the area is in meter square. So SI unit for pressure is what? SI unit for pressure is Newton per meter square or Pascal, right? I'll write it as PA. SI unit for the pressure is Newton per meter square or Pascal. And you should know that 1 Newton per meter square must be equal to 1 Pascal. 1 PA. ठीक है जी, ये आपको पता होना चाहिए. They can also ask you to define Pascal, and you write here that pressure is 1 Pascal PA when a force of 1 Newton acts perpendicularly to an area of 1 meter square. So whenever you have a force of a Newton acting on an area of 1 meter square, then the pressure is 1 Pascal. This is something that they can ask you, that define Pascal in paper 2. Right? Are you getting what I'm saying? आपको थोड़ी सी कन्वर्जन्स भी यहाँ पे आनी चाहिए. आपको पता है कि 1 सेंटीमीटर इक्वल होता है 10⁻⁻² मीटर के, और आपको ये पता है कि 1 सेंटीमीटर स्क्वायर क्या होता है? 1 centimeter square is 1/100 meters. That is one over 100 meters into 1/100 meters, right? Because 1 centimeter 1/100 meter की equal होता है ना. So 1 centimeter square can be written as 10 raised to power minus 4 meters square. Sometimes you will have to convert from centimeter square to meter square in the questions. We do that. तो ये आपके पास है pressure, simple pressure, right? ठीक है जी. अब हम चलते हैं hydrostatic pressure. Let's talk about hydrostatic pressure. Hydrostatic pressure जो है, you should know that the pressure is force over area by all means. ये आपको पता है. For example, I have a chamber like this, which consists of some liquid. Right? There's a chamber here, which consists of a liquid all the way. And I immerse a cylinder here, for example, like this. There's a cylinder, or I take a liquid column from this chamber. मैंने एक liquid column को उठा लिया इसमें से एक pot यहाँ से मैंने ले लिया यहाँ पे. ठीक है. अच्छा, इस liquid column का कुछ weight है, that is mg. इसका कुछ weight है, I'm going to write that as mg. ठीक है. The weight is acting downwards here. That is given by mg, the weight. So we have here the area of cross section is A. I'll write it as A, which is the area of cross section. Area of cross section that we have. So यहाँ पे आपके पास जो height है यहाँ तक, that is, I'll call this height h1. यहाँ से लेके यहाँ तक जो height है, that is h1. So यहाँ से लेके यहाँ तक जो height आ रही है, I can call that h2. If I talk about this height of the container, that is delta H. Now this height of this liquid column is nothing but delta H. So delta H is given by what? That is given by H2 minus H1. H1 टॉप से लेके यहाँ तक इसके कॉलम के टॉप तक की हाइट है. ये लिक्विड कॉलम मैंने एक ले लिया, एक चैम्बर उठा लिया यहाँ से, उसकी हाइट है. ठीक है. That is the height of the liquid column till here. उसके बाद क्या होता है जी, हमारे पास, हाँ जी, लिक्विड पूरा भरा हुआ है और मेरे पास मैंने क्या किया कि मैंने यहाँ पे जो है वो इसको एज्यूम कर लिया कि H1 है और ये इसके एंड तक H2 है. अच्छा, इसका वेट, ठीक है, समझ आ रही है जी सबको? इसका वेट जो है वो mg है. इसको हम वेट कहेंगे. मैं यहाँ पे इस तरह से लिख देता हूँ. This is mg. I can write here pressure is equal to force over area. So I can write here the pressure as weight of the liquid column over the area of cross section. And we can write easily here that weight is mg, area is A. You're very well aware of the fact that अच्छा, इस fluid की अगर density हम कर लें, that is rho. This is the density of the fluid. और ये fluid chamber आपने fluid से बनाया, right? इसको आपने column दिए जो liquid का. ठीक है जी. Rho is the density of the fluid. अच्छा, मैं यहाँ पे अगर गौर करें आप, तो मैं लिख सकता हूँ यहाँ पे that mass is density into volume. Can I write it like this? जी. This mass of the liquid can be written as density of the fluid and the volume of the fluid that I have taken. This is the volume. And we can put it in here. This becomes density into volume times G over area. अच्छा, उसके बाद we can also write here that P is density, volume is area into delta H. The area is this and height is delta H of this container because delta H मैंने आपको बताया था कि it is the difference between the heights. So the volume is given by cross-sectional area into delta H. And I can put this expression here. This is area into delta H into G over A. We cancel this A with this A, and we find the change in pressure, the pressure as, right here, delta P as rho G delta H, where delta rho is the change in hydrostatic pressure. The symbol that we have here, delta, is the change. It means the change. So ये आप खाली भी रख सकते हैं यहाँ पे P is equal to rho G H, यहाँ पे O level में भी पड़ा हुआ है. ये आपके पास जो है वो फॉर्मूला आ जाता है. ये आपके पास यहाँ पे चेंज इन प्रेशर है. This is the density of the fluid. This is the gravitational field strength. This H is the depth of liquid column. So you have here the इस तरह से आप लोगों ने इसको करना है, right? Let us move ahead with the concept of the atmospheric pressure, right? What is atmospheric pressure? You know that the value of atmospheric pressure near the Earth's surface, near the sea level, in fact, is what? That is 1.01 into 10 raised to the power 5 pascals. So atmospheric pressure is at sea level is given by 1.01 into 10 raised to the power 5 Pascal. And for example, we have here a tin can which is intact and it's an empty can with air only inside the can. So we have something of this sort. There is air here inside the can and it is intact. And the reason for being intact is that the pressure that is inside is the same as the pressure outside. So the shape does not change at all, right? However, if I'm going to write here that atmospheric pressure is the same inside and outside of the sphere. If, however, we have air removed from the can, it's going to have this distorted shape, right? And why is that? Because the air has been removed and it's only the outside atmospheric pressure which is in fact acting. You see like this. What happened is that there is no air inside, and what happened is that the atmospheric pressure has caused the tin can to crush. So if we realize here that if an object is there underwater, for example, if a person is swimming underwater, what's going to happen is that this this height that we have is, for example, h, or I'll call that delta h, and this is water all the way. This is water. इस तरह के सवाल बहुत ज्यादा आते हैं कि आपके पास वाटर है, यहाँ पे जो एटमॉस्फेरिक प्रेशर है वो ऊपर से आ रहा है. We'll call that P naught, and this is the atmospheric pressure. So this is the atmospheric pressure. The total pressure at this point, at this depth, I'll call this depth A, is going to be what? The total pressure at depth A is, in fact, the atmospheric pressure plus atmospheric pressure plus rho g delta H, right? We have here the atmospheric pressure. I'm going to write here P naught. This is P naught. This is rho g H. This is the pressure due to the liquid column here. And you can get the total pressure at this point. P naught is the atmospheric pressure. No? P naught plus rho g H. P naught is the atmospheric pressure at sea level. जब भी आपके पास इस तरह से होगा तो आपने, और कभी कभी क्वेश्चंस आ जाते हैं कि उन्होंने आपको एक पूल दिया होता है इस तरह से, और इसमें पानी होता है, तो वो आपसे कहता है कि ये पॉइंट ए था और ये पॉइंट बी था, उसने हाइट्स दी होती है, एक ये हाइट और एक ये हाइट, तो वो आपसे कहता है कि डिफरेंस इन प्रेशर फाइंड करें. तो कैसे करेंगे? अगर ये H1 है, ये H2 है, तो आप दोनों के प्रेशर्स निकाल के सब्ट्रैक्ट करें. अब अगर आप करें P नॉट प्लस rho g H2, the pressure at B, minus P naught plus rho g H1, तो ये क्या हो जाएगा? ये हो जाएगा P naught plus rho g H2 minus P naught minus rho g H1. इससे कट जाएगा, इससे कट जाएगा, and you'll get what? You'll get rho g delta H. H2 minus H1 is delta H. Got it? इस तरह से आप लोग जो है वो डिफरेंस इन प्रेशर फाइंड कर सकते हैं बिटवीन ए एंड बी. इस तरह के क्वेश्चंस आ जाते हैं आपको. Got it? अच्छा, उसके बाद हमारे पास चीज आती है एक एटमॉस्फेरिक प्रेशर. ये हमने ये कर लिया. एटमॉस्फेरिक प्रेशर क्या चीज है? How to measure the atmospheric pressure? Let us talk about that. I have measurement of atmospheric pressure. We have here a measuring cylinder, and this measuring cylinder consists of some mercury, for example, like this. This is the mercury. Okay. It's a 1 meter long test tube that we have. It's a 1 meter long test tube. I'll call this the mercury barometer. What I'm going to do. We have here the mercury barometer. What happens in mercury barometer? We have a dish containing some mercury all the way like this. And we have here, we will invert this test tube over this trough so that we get something of this sort. Now, experiments show that this height from here to here is given by 0.76 meters of mercury, of Hg. Hg is the symbol for mercury. You can also write here 760 millimeters of Hg. It's 760 millimeters of Hg. If you look closely here, this is the vacuum that we have. This is the vacuum that we have, and this is 0.76 millimeters of Hg. Why is this height 0.76 millimeters of Hg? है, आप अगर यहाँ पे गौर करें तो एटमॉस्फेरिक प्रेशर यहाँ पे भी उतना ही पड़ रहा है, यहाँ पे भी उतना ही पड़ रहा है जितना इस डेप्थ पे पड़ रहा है, जितना इस डेप्थ पे पड़ रहा है उतना ही यहाँ पे यहाँ पे यहाँ पे यहाँ पे पड़ रहा है। अच्छा, अगर आप थोड़ा गौर करें तो वी कैन राइट हियर P नॉट as the atmospheric pressure as rho g delta H, and we can write here in front of P naught 1.01 times 10 raised to power 5 pascals. Rho is the density of the mercury, that is this, ये given होती है. This is 13,600. G is 9.81. 0.757 meters, which is in fact equivalent to 0.76 meters of mercury. So yes, this height is given by using this expression of 1.01 into 10 raised to power 5, right? ठीक है, इस तरह से आप इसको कैलकुलेट करें. एक और चीज हमारे पास होती है हाइड्रोलिक सिस्टम. इसका भी सवाल एक दो आए हुए हैं, मैं इसलिए आपको एक करवाना चाहता हूँ. Hydraulic jack is a perfect example. Hydraulic car wash is a perfect example. And what happens in hydraulic systems is that you have a piston like this, which is filled with incompressible liquid. There is a liquid which is incompressible. This piston is like this. This piston is like this. This piston can move here. This piston can move here, or other way. We have a force which is being applied at this piston. This is Px. This is Fx, the force. And the area is Ax over here. I just told you that it is filled with incompressible liquid all the way. Okay? The liquid is incompressible. If we have a car here, like this car can be lifted up if you apply a force here. If you apply a force here, this car can be lifted up all the way, and the force that would be applied here would be Fy over an area which is Ay. Now what happens is that when you apply a force, according to Pascal's principle, the pressure is transmitted equally in all dimensions. Equally in all dimensions. Everywhere the pressure is going to be the same, and it's going to hit the walls of the pistons with the same pressure, because the pressure is transmitted equally in all dimensions. It is going to hit here all the way, and the pressure is going to be the same. अच्छा, अब होगा क्या? क्योंकि ये एक इनकम्प्रेसिबल लिक्विड है, तो इसके अंदर एयर बबल्स वगैरह तो होंगे नहीं, तो जितना प्रेशर यहाँ पे होगा वो सारा के सारा ट्रांसमिट हो जाएगा. So according to Pascal's principle, the pressure is transmitted equally in all dimensions, right? We can say that the pressure here is Px, which is Fx over Ax, and the pressure that is acting here is Fy over Ay. Now, if you know that the pressures are equal, we can equate this Fx over Ax is equal to Fy over Ay, and you can simply calculate the force Fy as Fx over Ax times Ay. लेकिन आप एक कम फोर्स यूज करके एक बड़ी फोर्स बना सकते हैं यहाँ पर. ठीक है, आप एक कम फोर्स, इसका फायदा ये है कि आप एक कम फोर्स यूज करके एक बड़ी फोर्स बना सकते हैं. लेकिन आप ये भी सोच रहे होंगे कि isn't it a violation of conservation of energy? You are getting something out of nothing. आप सोच रहे होंगे ये बात कि कैसे हो सकता है कि आपने कम चीज से एक बड़ी चीज बना दी. देखिए यहाँ पे फोर्स थी 20 न्यूटन फॉर एग्जांपल एक्स पे, और इसका एरिया था 4, तो आंसर 5 आएगा। यहाँ पे आपके पास फोर्स 100 है, इसका एरिया यहाँ पे जो है वो 20 है, तब भी आपका आंसर 5 आएगा। तो आप एक छोटी फोर्स से एक बड़ी फोर्स पे जा रहे हैं, तो एरिया भी उस तरह से हो रहा है। और दूसरी बात ये है कि जो वर्क डन है यहाँ पे इस पिस्टन एक्स पे, वो सेम वर्क डन यहाँ पिस्टन वाई पे होना चाहिए। तो अगर हम वर्क डन की बात करें in accordance with the law of conservation of energy, work done at piston X must be equal to work done at piston Y. So you can write here Fx into dx, because this is the distance here, is equal to Fy into dy. Work done हम पढ़ेंगे अगले chapter में. It's a complete chapter, work, power and energy. But you are familiar with this formula from your O level. That Fx into dx is the force of x and dx is the distance of x. अगर आप यहाँ पे थोड़ा और गौर करें तो फोर्स यहाँ पे 20 थी, चलिए ये डिस्टेंस मूव कर गया 5 मीटर नीचे की तरफ। अगर यहाँ पे फोर्स 100 थी तो ये डिस्टेंस सिर्फ 1 मीटर ऊपर मूव कर रहा है। ये 5 मीटर नीचे जा रहा है तो ये सिर्फ 1 मीटर ऊपर जा रहा है। तो देखिए यहाँ पे एनर्जी कंजर्वेशन जो है वो अप्लाई हो रही है और एनर्जी वायलेशन नहीं हो रही। आप कम फोर्स लगा के ज्यादा डिस्टेंस कवर कर रहे हैं और यहाँ पे आप ज्यादा फोर्स लगा के कम डिस्टेंस कवर कर रहे हैं। तो ये आप लोगों को लाजमी इस बात का आइडिया होना चाहिए। ये इस तरह से होता है कि हमारे पास एक मास्टर सिलेंडर होता है लाइक दिस, और यहाँ पे एक स्लेव सिलेंडर होता है और इसके अंदर लिक्विड इज फिल्ड। आप मास्टर सिलेंडर पे, दिस इज द मास्टर सिलेंडर, दिस इज द स्लेव सिलेंडर। आप जितना प्रेशर मास्टर सिलेंडर पे लगा रहे हैं वो प्रेशर ट्रांसमिट होगा स्लेव सिलेंडर पे इक्वली। तो ये हाइड्रोलिक सिस्टम की खुसूसियत है। ये ब्रेक्स के अंदर यूज होता है, आपकी कार्स के अंदर। मैं जो है कहते हैं विंड टर्बाइंस पे था, तो वहां पे भी हम लोग हाइड्रोलिक ब्रेक वहां पे यूज होती थी, जो विंड टर्बाइंस के जो ब्लेड्स होते हैं उनको रोकने के लिए, उनको ब्रेक लगाने के लिए ये हाइड्रोलिक सिस्टम था। उसके अंदर ऑयल था, हाइड्रोलिक का जो ऑयल होता है वो था, जो वो तीनों ब्लेड्स पे जाके जो है वो जब ब्रेक लगती थी तो प्रेशर ट्रांसमिट होता था, और प्रेशर की साथ वैल्यू आ रही होती थी, उधर एक आपके पास प्रेशर बार लगा होता था। ये आपके पास एक कार का ब्रेक सिस्टम है, देख रहे हैं। अच्छा जी, so what's happening here is that the diagram shows us brake system of a car. The pipes are filled with incompressible liquid. When a force is applied to the brake pedal, the pressure in the liquid increases and applies a force to each of the four wheels. यहाँ पे प्रेशर लग रहा है वो इक्वली ट्रांसमिट हो रहा है, यहाँ पे यहाँ पे यहाँ पे यहाँ पे। जितना प्रेशर यहाँ पे है उतना ही प्रेशर यहाँ पे होना चाहिए, उतना ही यहाँ पे और उतना ही यहाँ पे। The area of the piston connected to the brake pedal is 8 centimeter square, ठीक है, and the area of each piston connected to the brakes is 12. ये भी 12 है, ये भी 12 है, this is also 12, this is also 12. A force of 800 Newton is applied by the foot to the brake pedal. You apply a force of 800 Newton here. What is the force applied to each brake? Now the pressure which is acting here is F over A, which is 800 over 8. I'll call this piston X. Let's say that since the pressure is same everywhere, the pressure here is also going to be equivalent to this. So 800 over 8 is 100 is equal to pressure at this brake, which is F over A. The area is 12 of each piston. So the force applied to each brake is 1200 newtons. Measuring gas pressure. For example, I have here a manometer. It is a U-shaped container like this. And for example, यहाँ पे आपके पास लिक्विड था, यहाँ पे भी लिक्विड था। जितना प्रेशर आपके पास यहां पे है उतना ही प्रेशर यहां पे पड़ना चाहिए। जितना प्रेशर आपके पास यहां पे है, you should know that there is same atmospheric pressure, क्योंकि दोनों तरफ से एक्सपोज्ड है एयर से। Are you getting what I'm saying? Since atmospheric pressure is the same at both ends, both ends will have the same height, right? If I attach a gas with this, which has a pressure greater than atmospheric pressure, I'll call this gas A. What's going to happen is that we are going to have certain changes here. This is going to go here. This is going to go here, right? So the liquid level rises from here. And you see that there's clearly a height difference, which is H. अब आपको ये बात पता होनी चाहिए कि जो गैस का प्रेशर है वो यहाँ एक्ट कर रहा है, इधर उतना ही प्रेशर इस पॉइंट पे एक्ट करना चाहिए। जितना प्रेशर यहाँ एक्ट कर रहा है उतना ही प्रेशर यहाँ एक्ट करेगा ना, क्योंकि सेम लेवल है। Are you getting what I'm saying? जब लेवल सेम होते हैं मैनोमीटर में तो वहां प्रेशर्स इक्वल होते हैं, याद रखिएगा। ये बड़ी इंपॉर्टेंट चीज है, ये बहुत सारे क्वेश्चंस में आपके काम आएगी। जब लेवल्स इक्वल होते हैं तो वहां पे प्रेशर्स इक्वल होते हैं। अच्छा, यहाँ पे here we have the atmospheric pressure, which is P naught. This is the atmospheric pressure that we have. So the total pressure of gas at this point is equal to total pressure of gas at this point, and the total pressure at this point is P naught plus rho g h. आप हमेशा जो है वो एटमॉस्फेरिक प्रेशर में rho g h को ऐड करते हैं। This is the pressure of the gas. Whenever you have something of this sort, आपने O level में भी पढ़ा हुआ था कि the gas pressure is greater than the atmospheric pressure here, और gas pressure is 8 centimeter above atmospheric pressure. The gas pressure is greater than atmospheric pressure. Agar, if the gas pressure is less than atmospheric pressure, what's going to happen? I have here a gas, which is like this. We have, अच्छा एक बात याद रखिएगा, एरिया से कोई फर्क नहीं पड़ता ट्यूब के. The area doesn't matter. Cross sectional area has no effect on the pressure. Remember that. ये बड़ी इंपॉर्टेंट चीज है, ये भी आपको फायदा देगी क्वेश्चंस में. यहाँ पे ये लिक्विड लेवल यहाँ चला गया, यहाँ पे लिक्विड लेवल फॉल कर गया. अब जो प्रेशर यहाँ पे होना चाहिए था गैस का, वही होना चाहिए था यहाँ पे. तो देखिए ये 8 सेंटीमीटर बिलो चला गया एटमॉस्फेरिक प्रेशर. ये 8 सेंटीमीटर बिलो चला गया. तो प्रेशर एटमॉस्फेरिक तो ऐड कर ही रहा था, प्रेशर एटमॉस्फेरिक तो ऐड कर ही रहा था. The gas pressure here is now given by the atmospheric pressure minus rho g h. Here P naught is the atmospheric pressure. I told you guys. And remember that the cross sectional area, tube jitni badi zyada wide ho, doesn't matter. Cross sectional area of the tube has no effect on the pressure of the gas.